Hey, this is Kevin with AGL. Today we're going to do a quick tutorial video on programming your Naza V2 with the new Spektrum DX9. We're assuming that you already have your Naza V2 installed on your aircraft and a receiver. First thing we're going to do is take the DX9 and we're going to make a new model. So we have the radio powered on. We're going to depress both the clear and back switch and select new model. We are going to create a new model, and then we are going to select the model type. We want to use the airplane. If you want to go ahead and name your model, you can do that now, or you can name it later. For the aircraft type, we want just normal wing and normal tail, and all the gyros inhibited. Next, we're going to go to F mode setup. Under F mode setup, we want to select switch 1, and I like for my flight modes to be on switch B. Here, this one, this 3-position switch. So I'm going to take switch A and change that to switch B. I don't need a secondary switch because with Naza we basically only have 3 flight modes. And then we're going to go back to list. With the DX9, you can actually have the assistant speak to you and tell you which flight mode you're in, and you can select that here under spoken flight mode. And then we're going to go to channel assign and make sure that our channel 5, the gear, is plugged into our channel U on the Naza V2. When we go to our next screen, channel input config, we need to change this gear to channel to switch B. Go back to list, and we can scroll back up to the top. Now, if you go over to monitor, just by scrolling the wheel, you see that channel B is changing our flight modes. We have all 3 positions. So now we're going to bind the receiver with the radio. So we're going to shut the radio back down, take our bind plug and plug it into the receiver. And before powering up the aircraft, it's always a good idea to remove the propellers just in case this thing decides that it does not want to stay on your bench any longer. So we have the propellers removed, bind plugs inserted. We're going to power up the aircraft. Now you can see the receiver and both the satellites in this particular aircraft are blinking to let us know it's in bind mode. We're going to go ahead and remove the bind plug just so we don't accidentally plug it back in during our several power-up procedures here and have it go back into bind mode without. Now for the bind, we have our bind plug inserted. We powered up the aircraft. Like with any Spektrum radio, we're going to hold down the bind plug, and then while we're holding that down, we're going to turn on the radio. Just be aware that sometimes the Spektrums have a little bit of a hard time binding to all 3 devices on here. You've got 2 separate satellites and a receiver. You have to bind with all 3 of those different devices at the same time. So if you're holding the radio close to the aircraft and it doesn't bind, just try the procedure again and move the radio back just a little bit. I've found that most of the time when you have 3 separate components on the aircraft, it helps to have about a meter's distance. So I'm going to hold down the bind plug and then turn on the radio.
Binding. DSNX 22 milliseconds. Bind complete.
Alright, so we've got a good bind with the helicopter. Our screen has gone back to the normal home screen, and you can see we're currently in failsafe. So the next thing we're going to do is open up our Assistive Software. If you haven't already downloaded the Naza V2 Assistive Software, we've added a link at the bottom of the screen. You can download that, and you can also download the Quick Start Guide, which has a good section at the very back of the Quick Start Guide that you should print out, laminate, and take with you to the field. Because as you can see, we have the steady yellow flash for the fail-safe. The very last page of the Quick Start Guide goes over what all of the different flashes mean with this particular unit, the Naza V2, and it's always good to have that with you in case you have a compass calibration failure or anything like that. You'll know the flash pattern you're getting and what that particular flash pattern means. Alright, you heard the computer connect with the controller, and we have the steady dim green LED. You can see in the mode here that we have a solid green light to let us know that we are connected. We have it tracking our stick movements, and we're going to move to the basic tab right here. We're going to open up the basic tab, and this is where we're going to select the type of aircraft we have. If you're flying a traditional cross quadcopter, you'd select this with one motor forward. This particular flame wheel we have in the X configuration, so we're going to select it. Next you can do is go to the motor test. So if you're not sure if you have your motors going the proper direction, you can use this part of the Assistive Software to make sure that you have your propellers and your motors going all the proper direction. It's giving you a warning here to ensure that you have the proper power supply and you have the propellers removed for your safety. As we go around the aircraft, you can see that we are set up with motor 1, motor 2, motor 3, and motor 4. And we have the circles on our Assistive Software that let us know the rotation that the motor is supposed to be turning in. So motor 1 is always counterclockwise, motor 2 is clockwise, motor 3 is again counter, and motor 4 is clockwise. We have these 4 tabs over here that correspond with their motor locations. If you click one, it will actually spin that motor momentarily to let you confirm that it is spinning the proper direction. So you can click it and you can see motor 1 spin independently of the others. Same thing for 2, 3, and 4, just to help you confirm that they are spinning the proper direction. So when you have your first flight, you know at least the props are going the right direction, the motors are going the right direction. Once we're finished there, we're going to close this out, and then we're going to go to the mounting tab. Under this tab, it's showing you that your controller, you have the little arrow in the center of the controller facing forward. You need to make sure that your controller is facing forward with the arrow pointing towards where you want the front of the aircraft to be. This next tab goes over where you mounted your Naza V2 GPS unit. At the top of your Naza V2 GPS unit, you also have a little bitty arrow that needs to be facing towards the front of the aircraft. This is your compass, and if you have this facing the wrong direction, your aircraft will not operate properly. So on this flame wheel, we do have the GPS with a little arrow pointing towards the front of the aircraft up here. So that's set. The next thing we need to do is measure its position from the center of gravity of the aircraft, the very center point where our controller is located. So we need to measure on the X plane forward and back, the Y plane left and right, and then also the Z plane up and down. For this particular one, we have the measurements set on the X plane. I'm behind the center point of the aircraft, so as you can see over here, the green line means to give a negative value. So in the X plane, we are going to give it a negative value of -6 and then hit enter to write. For the Y, our GPS is slightly off to the left, so you can see the left is a negative value because of the green line. So we're going to take that and we're going to set this to -5 and enter to make sure that it's written to the controller. And for the Z plane, our GPS is of course sitting above the aircraft, which is also a negative value. So for the Z plane, you can just set this to -10 and enter to write it. If you put these in backwards, or you forget that the green is a negative value, then your controller is not going to help you operate the aircraft properly. It's going to yaw and do all kinds of crazy things. So you just need to make sure that when you're doing your measurements and putting these in, that you get the proper value. Green line, if you're off to the left of the aircraft, is negative value. If your GPS is on the right of the aircraft, it's positive value. Same thing for the X. If you're behind the center of the aircraft, it's negative value. If you're forward of the center of the aircraft, it's a positive value. And for the Z, I couldn't imagine anybody having a positive value, because your GPS would be below the aircraft, and more than likely your aircraft would be interfering greatly with your GPS signal. So we're going to move to the RC tab. This is the one that usually gets everybody confused a little bit. With the Spektrum receiver, we don't have S-Bus, we don't have PPM. All we can use is the traditional setup for your signals. That's why we have a wire going into every plug on the controller. You can see here in the receiver type, we've selected traditional, and you can see off to the left side here it gives you corresponding positions to actually plug in your servo leads. Some receivers are numbered 1 through 5, 6, or 7, however many channels are on the receiver. With this particular Spektrum, we have them listed: throttle, aileron, elevator, etc. And one thing to note with Spektrum is that channel 1 is throttle, whereas this is set up for typically a Futaba receiver, and channel 1 would be aileron. So you need to make sure to take that throttle and put it into channel 3, and your normal with Spektrum channel 2, which will be aileron, into channel 1. So we've chosen the receiver type as traditional, and now you can see our sticks as we move our rudder. Our rudder actually does move our rudder. Our aileron moves our aileron. Elevator moves the elevator, and throttle moves the throttle. If any of these were reversed, all we have to do is push the reverse tab over here. And you can see that when we give left rudder, we get left rudder on the screen. Right rudder, we get right rudder on the screen. With throttle, we advance it, and it goes up, just like on the screen. For elevator, we push forward, your indicator on the screen should move forward. You pull back, your indicator should move back. And the same thing for aileron. When you go left, it goes left. When you go right, it goes right. So if yours aren't doing that, just make sure to hit reverse. The next thing we're going to do is a calibration. So we can actually calibrate the endpoints for your particular controller and on the screen. So you can see all of the endpoints jumping all around. We're going to take and just move our sticks to every endpoint, and then reset into the center. And we look back at the screen and we see that we have everything centered. So we're going to click finish, and it's telling you that after the values, you just need to make sure that everything's set. Well, we're going to take our throttle and just pull it back down. The next thing we're going to do is to calibrate our mode switch. Now with this one, the mode switch is set to gear. But we set that up when we started our new model. We set that on switch B here. So as we move switch B, we see that we're moving from blue off to the right, attitude mode, which is in the center, and to just past GPS mode. To correct this, so that we actually get the GPS mode, our third mode, and attitude mode, we're going to hit our scroll wheel, move to servo setup, Then we're going to go down to travel and select our gear switch.
Flight mode 2, flight mode 3,
Now,
flight mode 1.
if you look on the screen and on your radio, you can see we're going to select our gear. It's set to 100, and we're going to reduce that until we see the slider on the screen move to the GPS position. Always give it about 2 clicks after that, just to make sure that it's well centered. And then when we move our switch, you can see that we get attitude.
Flight mode 3.
We're still too far off to the right,
Flight mode
and then
two,
when we come back, we get
mode 1.
attitude and GPS mode. So we're
Flight
going to
mode
move back
3.
to our third flight position and select it and reduce that so that we get into that last block right there. Now, I like to have this set as my fail-safe so that when you pull the switch all the way towards you, you get fail-safe.
Flight mode
Your middle
2.
is attitude mode.
Flight mode 1.
All the way back is GPS mode.
Flight mode 2. Flight mode 3.
Now we have a manual mode here that we could program in, but I just use fail-safe because doing aero photography, I really don't have a need to have a manual mode.
Flight mode 2.
So we have that
flight
set.
Mode 1.
We no longer need to be in the travel menu, so we're going to back out to the main screen. And
Flight mode 2. Flight
we're again
mode
going to
3.
confirm on the
Flight
screen
mode
that
1.
we
Flight mode
are getting
2. Flight mode
our 3
3.
channels.
Flight mode 2. Flight mode 1.
So next, we are going to go over here to X1 and X2. If you have a gimbal on your helicopter and you'd like to have tilt and or yaw, you can set that up here. You can also use either of these switches to adjust your gains as needed later on. Okay, on this particular flame wheel we have a gimbal. We have the H3 2D. So we're going to set up this slider on the back here to control our tilt. To do this, we're going to depress our scroll wheel and we're going to go down to System Setup. And here it's going to give you a warning to let you know that you're about to lose link with the receiver. And we're not terribly concerned with that. We have the props removed, so we're going to go ahead and tell it yes. Next, we're going to scroll down to Channel Assign. You can see that we already have our Auxiliary 1, which we're using to control the gimbal on this particular aircraft, assigned to Channel 6. So we're going to move on to the next screen, and we're going to go over to Auxiliary 1, and we have it on the right slider. If you prefer, you can have it on the left slider, or you can assign it to any other switch on this DX9. I like mine on the right slider, so I can use my index finger as I'm flying the aircraft just to pan up and down with our gimbal. So we have that selected. We're going to go back to List and go back to the main screen. Now if you look back on the computer, you can see that when I rotate the slider, you can see the tab for X1 moving. So that gives us control of our gimbal, and we have that set to tilt. So we're going to take that back to center. We're going to do the calibration for it. So we'll hit start and you'll see that the indicator's jumping all around. So we'll take our slider, move it all the way to one side and then all the way to the back, and then go back to center and hit finish. Now we have good control, good tilt control of our gimbal using our slider on the back of the radio. The next thing we're going to do is go over gains. These stock gains, they work fairly well for this Flame Wheel 450. If you notice some oscillation while in flight, then you need to back these gains down a little bit. If the aircraft is reacting a little sluggish, then you need to bump up the gains. General rule of thumb is to have the gains up about as high as you can before the aircraft starts to oscillate, and then back them down about 10%. So that finishes out the basic tab. We're going to move over to the advanced, and we'll go through this section fairly quickly. We look over to motors, and we usually just use the recommended setting for our motor idle speed. Next, you have the failsafe. You can choose which you would prefer your aircraft to do, to either land when it has a failsafe, go ahead and land at the position it's in, or it can attempt to come home and then land. I typically like to choose this, that way at least the aircraft will start to make its way back to me and then land. If you receive voltage warning to the point that it's going to start to land itself or you lose your radio link, I would like the thing to start to make its way back to me just in case I have it out over water or something like that instead of just landing straight down. Next we're going to go into the intelligent control. I don't typically fly this because I'm an FPV pilot. If you are more of a line of sight pilot, this is a great option. You can select this and you'll have your home lock and a course lock. So if you're just going to fly the camera out, then when you push away, it's just going to go straight away from you. When you pull back, no matter its orientation, it's going to come back to you. You would set this up the exact same way as we did with our mode switch. You just pick another 3-position switch on your radio and set up your endpoints so that they line up. Your little tab here lines up with the home lock and course lock and the off position. Next we're going to go into gimbal. The Naza V2 Assistant offers a gimbal control if you don't have one of the DJI gimbals with a built-in controller. One thing to note is that if you are using S-Bus as opposed to the traditional radio setup, with S-Bus you only have one wire going from your receiver and to the back of the motor controller. So if you have that, then you won't have anything going to your gimbal. So you'll need to turn the gimbal on and you'll see that it's given outputs for F1 and F2. So you would take F1 and plug that into your gimbal so that you can tilt the gimbal down. We're using the traditional setup, so we're bypassing that. Next we have the voltage tab. People like this, some people hate it. I use it in conjunction with a timer. Some people don't use it at all. I like to have the indicator myself. So I turn on the voltage protection switch, and you can do a calibration here if you have your aircraft plugged into a voltmeter to make sure that you're getting the proper voltage. You want to select what cell LiPo you're flying. With this particular unit we're going to be flying a 3-cell, so we should have about 11 volts. Right now we have 11.8 feeding into the aircraft. Then you have your first level protection. For our first level protection right now, we have set to 11.3. That's without load. Under load with a 0.6 volt loss, then our first level protection is going to be 10.7 volts. We have our secondary level protection set to 11.2 without load under a 0.6 volt drop of the load. Then we have a 10.6 volt for our secondary level protection. So if you hit the secondary level protection, the aircraft is going to start descending. So you need to be certainly on your way home. If you are flying with an OSD, then your battery will start flashing at you under this first level protection, and by the time the second one hits, it's going to start landing itself. So you are going to have to give your throttle position 90% or better to make your flare before this thing comes all the way down to the ground. Like I said, we typically will we try to fly a consistent battery load and a complete payload for the aircraft, so we use a timer in conjunction with this low voltage alert so that we usually have a pretty good idea of how much time we have left in the air. Next are your limits. If you want to set limits for yourself, then you can set your maximum height limit. If you want it to be 400 feet, then you can set that in corresponding meters. And the same second, you can also do it for range. If you're flying like this Spektrum transmitter here, it's probably only good for about 1,000 meters. So if you want to set this for 1,000 meters so you don't exceed the range, you can set 1,000 here, and when your controller hits 1,000 meters, it's going to turn around and start coming back to you. The next tab we have is tools. So this is the information that's coming from your IMU. If it needs to be calibrated, it usually doesn't, but if it needs to be calibrated, you can hit basic cal, It's going to tell you to keep the main controller still and hit yes, and it's going to start its calibration, and then you have success. One of the last tabs is update. Most of these are going to come with the latest firmware. You know, they're producing these things constantly, but if you buy used ones from somebody, you may want to check and update your firmware to the latest. You just make sure to plug it in, select the latest firmware. We already have 4.02 on here, but it's going to ask you if you want to upgrade anyway. So we're going to exit, and you can see the PMU. It's going to download at the same time, and there's no updates available for it. The final tab is going to be your user information, so you can log in and help keep track of your serial numbers and that sort of thing. And of course sign up for the DJI newsletter so you can find out when new firmware is coming out. The last thing we're going to do is disconnect from the computer, and we're going to shut down our aircraft, shut down our radio, put our props back on, and then we would go outside and do a compass cal prior to doing our first flight. But the compass cal procedures is really simple. If we have our radio on and we plug in our aircraft, if you want to do the compass cal, all you have to do is take our mode switch here, and you're going to flip it back and forth approximately 7 to 10 times until we get a steady yellow light on the aircraft.
Flight mode 3.
So we have a steady yellow light. We would of course be outside. Make sure to take your cell phones, your pocket knives, anything that may cause magnetic interference off of your person. Then we're going to pick up the aircraft. We're going to rotate around the axis of the aircraft 360 degrees, and you'll see the LED change to green. Then you're going to tilt the front of the aircraft down and do the same thing. And hopefully you'll get a good compass calibration. If the LED starts flashing red, then you've got a bad compass cal. You need to redo it, and probably in another location. If you try to do that in an area that has a lot of metal on the ground, or if you're on top of concrete, there may be a lot of rebar in the concrete, you're going to get a bad compass cal every single time. So just make sure to try and do it in a nice grassy area with a fairly clear canopy, so you can get a good GPS lock and a good compass cal, and then you're ready to fly. It's been Kevin with AGL. We hope this has helped you out a little bit. If you have any questions, please put them in the comments at the bottom of the screen, and check out our website if you'd like us to help you build an FPV or aero photography platform. We'd be more than happy to help you with that. And always please subscribe to our channel, like the videos. The more subscriptions we get, the more opportunity we'll have to make more videos. And thank you for watching.